All right, everyone. We are going to be looking at basically what do I want to try to say? Brute force, because we're going to be going through combinations of 6, 9, and 20. So the premise is of this, and if you're just jumping in, thanks for joining us today. We're going to be looking at combinations of numbers to achieve a sum. So let's just get the primer out of the way. So if you're new here, thanks for joining us. I'm Sam. This is what we. Hey Nico, how are you doing? Nugs 6, 9, 20, and close that out. And we're wanting to find a sum of 50. Combination No, what I'm going to do is I'm going to write an algorithm to look for combinations of what combinations of these to achieve a combination of, because it was basically, so I don't want to get into trouble. There's a franchise of restaurant that sells chicken nuggets in these combinations, and I want to be careful. And combination of orders to get 51. So how would I get 51 nuggets out of just these combinations right here? So when I remember, I think this was like week 3 or week 4 of the MIT class. It was crazy how and this took me a while. The first 3 weeks took me about 2 months to figure out how to get through, and I don't think I ended up going all the way through the entire class, the CS class, because that was where the idea for this YouTube channel came, because there were so many gaps between, because lesson 1 was create a function to take in your name and print it out. The second function was the prime numbers, which then that took me, I think, a month, and then the chicken nuggets took me another month and a half, 2 months. So that was when I realized how smart people were that go to MIT. And MIT is a university. It's Massachusetts Institute of Technology or for Technology. I can't quite remember. But all right. So there are a lot of things here that we need to handle. And I've solved this a couple of times. I have not looked at this in years, but we're going to go ahead and just get started with it. So we're just going to do this without having this in a function, because we kind of jumped into the function yesterday a little too fast. So we're just going to go really slow with this and think about this very human brain like, because it's like, all right, so we need to check all these combinations. So the way that I like to think about this is, the first way that I looked at this is I thought about this as like an odometer or an old style clock. So I'd have 6, 9, 20. I'd have 0, 0, 0, and then I would roll this up. 0, 0, 0. That would get me 6, right? Then we can do this a variety of ways. We can go 2, 0, 0. What does this get us? And I forget how I set this up as a while loop, but this is what, so we need to do a max and a min, because what is the largest number this could be? So it'd be 51 divided by 6. So what is that? 51 divided by 6. So, because we don't know exactly the combinations, but we know that we wouldn't do this 9 times, because 9 times 6 is 54. So we would not loop through this 9 times. So that is a great starting point. Does that make sense? Let me go back here. What was that? 8? 8. Oops. So dot, 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 8. That's a horrible 8. Let's try that again. There we go. So this is the maximum combinations, because of course if 6 and 8 goes into, so that's 48, and then everything will be less than that, because 9 is greater than 6 and 20 is much greater than 9, which is greater than 6. So that's kind of the premise. So we would turn these wheels, these combinations. So once we got to 8, so the way that I like to describe this is alpha, kind of like an alpha combination. Well, before we go into alpha combinations, so if we have a 1-digit number, let's go in here. Let's do a little bit of human brain stuff. So we have a 1-digit number. How many combinations are there to this? There's 10, because it's 0 through 9. Those are 10 digits. So if I have a 2-digit number, how many combinations can this be? Oops, that looks like 11. That's 100, because each one of these can be 10. And the easiest way is you can just multiply this by 10 times 10, because there's 10 combinations here and there's 10 combinations here. 10 times 10 gets us 100. So there's 8 times 8 times 8. Or what we could do to really make this efficient is we could take 51 divided by 9, and then 51 divided by 20. So if we look right here, so we could speed up this algorithm much, much faster. So our 6s, so the looping through, so we're only going to really try 8, 5, and 2. Yeah, yes. Okay. Yes, you're exactly right. I don't know. I don't want to get into the saying anybody's not letters. Yep. Because I don't know. I know I'm so small, but there's copyright infringement, branding. I don't want to say their name at all. I just wanted to stay away from it. But you're exactly right. All right. So if we go back here, that is 8 times 5 times 2. So there is only 80 combinations. That's kind of interesting. There's only 80 combinations of these numbers. So we're going to brute force go through all 80 of these combinations to see and try them all. We're going to have 0 6s. We're going to have 0 since I don't know. It's probably I probably wouldn't get into any issues, but I don't want any more problems than I already have right now. So I don't want to say anybody's name and them say that I was being disparaging. I just want to stay away from that as much as possible, because I think even in the MIT lesson they referred to it as a famous restaurant food chain. So, all right. So we need to start getting some variables around here. Let's see. Do we want to do 6? Here we go. Combo 6. Did I put a space in there? Sorry. And 0. Combo 9 equals 0. Combo 20 equals 0. All right, let me check something. Okay, thought I heard. So really, num of nugs equals 51. So this is what we're going to search for. Let's do max. Here we go. Now I know what I want to do. Not max. Max. Don't know why it's suggesting that while I'm typing it. It's like, oh, I think I know what you mean. Well, yeah, because I just wrote it. All right, so here we are. So now we're going to take, so if we look really, really close right here, we need to utilize floor division again because I want this whole number. So I don't want this remainder. So I'm going to take divided by floor division divided by 6. Floor division divided by 9. Floor division divided by 20. Nico, were you here when we went over floor division? What is it doing? Because I don't want to fly through this too quickly and not go over it. Okay. Don't know why I like the numbers being close here, but when I do addition, I want spaces in between it. I know that doesn't make any sense, but it is. So now, all right. So if we're going to be checking all of these combinations of, so right now, what was that? 8, 5, and 2. 8, 5, and 2. So let's get rid of this and delete. I didn't delete a lot of it. Delete. Okay. So 8. I want my brush back. 8, 5, and 2. So we're going to wheel through this 0 through 8. So we need to include 1. Suggesting feature is very useful. Just type the short name and something and then press yes. But if we were looking, it was adding, when I was adding max in front of combo, it was like, oh, wait a minute, you got combo. We know that. And then it was adding it before. So it was, now if I, let's see if I do max and then I can finish that, yes. But it was suggesting while I was creating inside the variable. It was really weird. All right. So we need one for loop for the 6. So it's a nested list. So it's a triple layer because we need all these wheels. We need to check this, and we can argue that maybe, I don't know, would it matter? Would it matter the order of going through these, having 8? Would it matter if for I in range would this matter? If it was on the outermost loop, you can just accept it and then change the number to 20. Oh, yes, okay. All right. So I guess I'm trying to think logically through here. Would this... I don't think it matters. I think I vaguely remember I tried having 2 up here, doing an outer loop of 2, because I still go through here 6 times. Because I'd still be it would still be 80 combinations. I don't think if I ordered the loops it would be any faster. So, all right. Now, here is one thing. I need to increment by 1 because my floor division gets me to here, but I actually need 8 included. So I need to add a 1 to this. Oh my goodness. All right. Then for J in range max 9 plus 1 for HIJK in range max 20 plus 1 parentheses close. All right, so now here we are. So if you're just joining us, what we're doing is we are trying to take the combinations of 6, 9, and 20 to come up with 50. And the way that this premise is there is a national chain in the U.S. of restaurants that serves chicken nuggets. And let's say you are really hungry and you want 50 chicken nuggets. Is there a way that you can precisely order combinations of a six meal, 9, and 20 and actually get 51? And the answer is yes. So we're going to be doing a brute force algorithm to check all of the combinations. And we did a little bit of math here to decipher so we can be very pointed, so we don't have this algorithm just run amok and check forever. We're actually limiting the numbers that we need to check, and we proved that there can be no more than 8, because 6 into 51 can be no more than 8, 9 into 51. So let's just say they ordered 48 divided by 6. That would be exactly 8. So this is why you would want to do this and be like, okay, hey, this is where we are. And then what we're going to do is we're actually going to output all of the combinations, because what you're going to find very interesting is there's more than one combination to achieve most of these numbers. All right. So now we need to have something to increment, right? Because we're going to then multiply these combinations. So because 6 plus 9 plus 20. All right, so I just need 10 more. So you see where I'm going with this, and then we're going to output this to a dictionary, and we're going to say like 6s, and for 6 combinations we need 2 of them, 9 combinations we need 1 of them, and 20 combinations we need 1 of those. All right, does that make sense? Let's see. So now we need to count. We need to have our count equals 0. Then we need to have our we need to make this a dictionary. Combination open close. So we just created a dictionary. So now we need a test. Okay. So each time through, we're down here. We need to identify this better. 6 piece, 6 count, 6. Can't start. Okay, do you guys know the variable rules? Can't start with there's 3 of them, and I've already forgotten what they are. Can't start with a digit. Can't have a special character, and maybe can't have a space. I feel like I made a rule when I was really teaching seminars a lot that there were 3 rules for variables. Maybe can't have a space. I think that's the 3rd one. All right. So this is not legal because it starts. Yeah, it's throwing a syntax. Yeah, because it should be pointing at the digit. But I can go completely legal. Just like that. I have not checked the sizing of the... Okay, good. Everybody can see everything. Let's get this up here. All right, cool. There we are. I may need to go check on some people in the house and make sure because they have a busy day today. I did not announce that I am live right now. At everyone, I'm live. Okay, there we go. And send. Yes, I mean it's my channel. I typed everyone. I know that I'm live. Thank you. And I've unmuted everything on Discord, Nico. Thank you. Let's see. Let's get back here. All right, so we need to make this better. Combination 6, then combination 9, not that 9, and combination 20. Okay. Do we want to have a variable? Now we could just do... All right. So our count equals... Because the first time through it's going to be 0, 0, 0, 0. Right? The next time through it's going to be 20. Because we want to check the zeros. I know that sounds... Do we want to check the zeros or do we want to start with ones? Because we know 0, 0, 0 is not going to do it. So that's kind of stupid. All right. We can jump start this a little bit. I may need... Give me a second. Check on my... Been getting a lot of spam texts and a lot of spam calls and a lot of... Oh my gosh, I got an email the other day that was from government officials for me to collect my $5 million gift that they found for me. I was like, my goodness, yeah. The Attorney General emailed me. The head of Homeland Security emailed me. All right, so we need to take... No, this is wrong. We do need to check zeros because it can't be 0, 0, 0, but it can be 0, 0, 1. Okay. I knew when I was doing it, it felt weird. Because technically, yeah, because I need them to be able to be 0. Yes, it is. It is a very big scam. You're exactly right, Nico. All right. So I'm going to do this, and I got to go check on make sure a kid's up and moving. All right. Combination 20 times 20, the count, plus combo 9 times 9. Get some parentheses in here. 9 times 9. Did I move that? Whoa. Then plus combo. Still forgot my parentheses. Combo 6 plus times 6. All right. Does everybody know what I'm doing right here? Let me go check. And then now I need to check if count equals, no, equivalent, not equals. Do this. Print boom 9. Let's just check this real fast. See if this worked, because this, I'm pretty sure I'm really close here. So let's run this. And print count. That couldn't have been done already. Am I already done? Yeah. Okay. So gee whiz. Now we need to put this into a dictionary. But I thought there was a lot more to this. But I want you to look really close. We need to get this all cleaned up. But yeah, look. There's 3 combinations to get 51 chicken nuggets. And I guess I did not remember that. So how low can this go? But yeah, if we had a count of 1 count of 6 and 5 counts of 9, I get 51. 4 counts of 6, 3 counts of 9, I get 51. 7 counts of 6 and 1 count of 9, I get 51. So, hang on. Oops. Yep. All right. I'm just getting a lot of texts today. Oh, I think I know. My folks need to go take care of something. All right, I need to go check on my daughter. I will be right back. Give me about 90 seconds, and I should be back. All right. All right. Thank you so much, Nico. You're absolutely awesome. All right. Let me check and make sure. Sorry, everybody. My daughter's got some plans today, and she's got to get moving. Okay. So, well, this went... I guess I've done this enough times that this all made sense, and I think I sped up the number of combinations. So... Let's let's start putting this into a dictionary. And because right now this output doesn't mean, you and I know what this means, but if we were to be outputting this to someone, they're like, what in the world? What is this actually? What does this identify? So let's get this going. So we could, because I remember what I also did is I had a variation of this where I took the numbers. So we could write this in and say if this count isn't in here, add it to it. But if it is, move on. Because as you go through these, as you increment up, the combination of 6 was 1, and then it was, we could set this as a parameter in the algorithm that the first occurrence, it will lock in the first occurrence. So what happens if we wanted to get all let's change this to 101. Let's check how many these are. Whoa, okay. Now, this is cool to me. We have, so there are 3 combinations to get 51. 1, 2, 3, 4, 5, 6. Now there's 6 different combinations to get 101. And I don't know. How low can this go? I can't remember. Because once it starts, then you can get every combination there is. Whoa, really? That was 44, 43. Okay, so 44 is the lowest number of combinations that you can get, and then it can just go up from there. So let's tweak this a little bit and have it. Yes, Nico, that's a great point. So if you're just joining us and you've not hit that like button, go ahead and do me a favor and hit that like button for me. And if you are brand new to this channel, this is what we do. We talk about Python stuff, going from human brain to Python brain. Go ahead and make sure you're hitting that subscribe button and notification bell as well, because, well, I think I'm going to have to be talking for a minute and think about it, but I think I have a live stream for tomorrow, because I've been live streaming every day for a week now. I was a little surprised. Saturday is a bad day for live streaming. No one checks it out. Sunday's pretty good. Shockingly, Friday is a very good day. So let's see. Everything is showing that I'm live. Is it? It is. That's weird. All right. I got an email from somebody who's yesterday, and actually at first it was so official I thought it was YouTube telling me that I wasn't going to be able to live stream because my views are so bad. But it was someone from doing SEO search. All right. So we've done a lot of the heavy lifting here. But now what happens if we change this parameter and we want to start and we want to get all the combinations from 44 through 101, and we wanted all the different combinations so that we could just go and review it for later. All right. So we start out with beginning. We can't do max and min because those are already, so begin nugs equals 44 and end nugs equals, right now let's do 101. All right, so first thing, how would we do this? We could just do an or we just start, and then also, oh, we need to change this because we just, what else do we need to change? Let's see, was this in here anywhere else? We need to look and see. Yep. Change end or count. We're going to do this super lazy. Beginning. Super. Whoa, 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 whoa. All right. Everybody know what I just did there? Okay, so first we need to get this output. Well, we can handle this output later. We need to get this into a dictionary. So as this is going through and we're finding, we need to remember how dictionary behaves. So we're actually going to be passing in a dictionary into a dictionary. Does that make sense? Because we're going to have multiple combinations. So inside this dictionary, it's going to look something like this. Count. I have to remember if, I think, help. I need to look at something and then we can talk about it. I can't remember if this is hashable or not. Then we can talk about hashable for a second here. Dir on int B, C, D, E, F, G. Yep, okay. So we can just pass in a number into a dictionary. So let me show you. Dictionary 51, then dictionary 2, or let's run this. We can use this as our example. All right. We're going to use this example right here. So dictionary, brackets, and we got 101. Then the dictionary, and it's going to be 6, 0, then 9 of them, then 20, one of them. Curly brackets, and curly brackets. So what in the world am I doing right here? So what I'm doing is, if we go through and we have the beginning combinations of 44 and 101, I have got to figure out a way to distinguish this. So for count of chicken nuggets of 101 chicken nuggets, this is my combinations. For combination, for a 6-pack, a 6-meal, a 6-count, I need 0 of them. For a 9-count, I need 1 of them. And for a 20-count, I need 1 of them. So this is our design. Now, the key value, if you've not messed around with dictionaries, very powerful, a little bit tricky. So this is how you test to see if the contents, this is what, so basically, if a found answer, because as we're going through, let's change this back to 51. Run. Oh, so check this out. So see, this is exactly what I wanted to show. Yep, this is not going to work. We're going to need to change this. So check this out. While count is okay. I digress. We do need to handle some things. So our human brain goes, okay, I want to include this in here, into this dictionary, because 44 is not in here. Not in here. Okay. That's actually a pretty good terminology, language, syntax for the dictionary. 101 in D. Okay. How in the world does this work? So when you're asking for the contents of a dictionary, it defaults and looks at the key. So as we're going through here and we're looking at this, it's going to go, we need to do a check. Hey, is this combination count in the dictionary? If not, let's throw it in there. All right, so let's get this going. So basically, is this a whole number? Is count in between? There we go. Is count in between? That's what I want to do. Check this out. If count, this is what I love about Python, and this is what I hated about SQL. You had to do a between. I just didn't like the betweens in SQL, but I love this. So beginning, because my brain I want you to look at this. Greater than or equal count. So basically, if you look at this on a number line, don't worry about exactly the wording, because I'm not going to say this quite right, but I want you to look at this. Beginning is the smaller number. End is the bigger number. And count is right in between. And it can be equal to, or it can be less than. So if you look at your chevron signs, this fits smack dab in the middle. It can be equal to, it can be greater than or less than. And so then if this happens, what we're going to do is we're then going to do a check. So if this is a number that's in between these, because this is our min range and this is our max range, we now need to test and see if it's already in the dictionary. Okay. If count in, helps if I spell combinations right. And we're going to move this down here just to make sure. If count, actually, not in. So let's go about this. So when this first thing happened, if this was not in here, if this was not present, we'd want it to write it to. We need to add it to this dictionary. So if this is not in, now we want to do stuff. So we want to take our combination, and this was one way to do it. So now we're going to look at 44. So D, then 44. So now check this out. So same, because I passed in a dictionary. So this is my key, and now I'm going to create the variable. Oops, sorry. I need to create the variable. Create the key to assigning to the value. Assigning the value to the key. Sorry, I said that backwards. So now I'm going to go here, and we're going to assigning 44, the first occurrence of 44. So that is a 6. There's one of those. Then 9, and there's 2 of those. And 20s. How many 20 counts are there? There are one of those. So I close this out. So now check this out. So now here's my count of 101 And here's my count of 44. 44 count, and then here's my dictionary of it. So, all right. So from our human brain to our Python brain. Sorry, I did some work around the house and I was leaning over and my back is all beat up. All right. So if it is not in, and then we want to take our count. Just like we did here. This is our syntax to get this to work. Then I'm assigning my key. So it will be our 6. Make it a dictionary, Sam. 6. Combination of 6. Let's probably bring this over a minute because I have a feeling this is going to go a little bit over. And nope. 9. And 20. Just like so. All right. Does that fit? Let's bring this over here. Can you see around my big old noggin? Yep. Okay. Hope everyone is doing well today on this Sunday. All right. So we don't need this. And how about every time through we print the combinations? Helps if we actually do print. All right. Run this. Interesting. Okay, this should not be. This should not have more than. All right, anybody know why I messed up and have too many 49s in here? This is a complete order of operation problem. I'm outside this test. So if I were to have printed combinations, no, that should have handled it. Okay, now I want to look at this. All right, that is cleaner. That should not have. Oh, it's printing every single time through. All right, okay. So I was redundantly printing this off. Now, here we go. So check this out. Here from 44, 44, 45, 46, 47, 48, 49, 50, and 51. So we could go, hello, how are you? CBD, how is your day going today? We're checking and doing some brute force calculations on combinations of chicken counts, chicken nugget counts. So what we've done right here and what we've proven is there is a way to go through and get all of the combinations. So now let's clean this up a little bit. And so we know we can start at 44. So check this out. Let's practice some unpacking and let's clean this up. So we're going to go back through, and we're going to print this out for count in range. So check out what I'm going to do here. Then end count. Get this back in here. I think I saw somebody. You're an undergrad student studying Python, SQL for data science. What else? What else can you do? Well, what do you want to do? Because what I'm finding is when you get to those levels, you can pretty much do whatever you like, because that can get you into a. So what industry interests you? Because if you can do that, you can get into basically any company, because any company of size or stature is going to need a data analyst, data scientist, data engineer. And then you just start learning about the business, and they're going to want to hear what you have to say. All right. So what am I starting to do here? I'm going through my range, and then I'm going to be unpacking this, because right now this is pretty clean, but it's out of order, because as I approach these combinations, where was it? Yeah. So as I approach these combinations, as they happen, as I turn the dial wheel of my counts, 0, 0, 0, 0, 0, 1, and there's only two combinations here. So 0, 0, 2, and then this were to go back to 0, and then we'd be 0, 1, 0, 0, 1, 1, 0, 1, 2. Then we'd start back over, kick up to here, 0, 2, 0, and so on and so on and so forth. So as we are coming, well, have you been around here before? So knowing, not to divulge too much, but we had on my team, on my old team, there were 8 of us. Our boss was, I would basically say basically a full stack. He could do all of it. Then we had project managers, we had data analysts, we had some visualization experts, an automation person, which was me, an architect, and he could code some. But the overarching theme was the people who were successful were problem solvers. The people who struggled would get stuck in these rabbit holes, would get stuck in circular arguments, didn't have focus on. Still here? Can everybody still hear me? All right. Am I back? Because I think my OBS just threw up, but it just said it's fine. So if I'm back all the way, if Nico, you're still here, can you give me a little thumbs up? Let me know. All right. So the reason why I call this Bob Rossing. I'm back. Okay, good. Thank you. All right, CBD. You're gonna algorithm. The reason why I use the word algorithm a lot is to make it sound less scary. An algorithm is just decisions in order of operations to get to mimic human behavior and to mimic human decisions. So when you're wanting to do these things, you need to have a large amount of information that shows that you can solve problems. I can think through a problem. You can give me anything, and I may not know how to do it, but I know ways to attack it, and I know ways to solve it, because you're telling me where we are. You're also telling me where we're going. And my job as a problem solver is to blaze the trail and find the path to get us there. That's my job. Your job is to give me a beginning point and an end point, and then I figure out the way. And that's when you start stepping on everybody's toes in between, that's when these things don't happen. But when you get a good business partner that gives you the end point, gives you the start point, and then gets out of your way, then you can do a lot of good stuff. All right, Nico, thank you. Okay, so what I'm going to do here, let's just print so you don't have to worry about these arbitrary. Okay, so here we go. So now I have these in order. And since a dictionary is hashable, I'm going to now take this count and I'm going to pull from here. And so now combinations. Combination, putting in count. So check this out. And have you guys seen this? Were you guys around the last few times to see this? What I'm doing, I'm suppressing the new line. So all right, so this is a little ugly. I don't like this. Let's give me a space. So I don't really like that this is a dictionary. So let's start unpacking this and going from there, because what I want it to do is I really want our count. Then I want 6. So we can play around with unpacking this. So do I want the quantity of 6? 1, 6 counts, 9 counts. Yeah. How about we play around with this? So now we need to, so when I just, let's combination count. What am I getting? Because this is, I actually made this mistake the other day when I was concatenating lists, or what I thought I was concatenating lists, and understanding what you have. I mean, this understanding the form, understanding your data. So CBD, I'm actually working on some content for LinkedIn because I'm trying to find a new job right now. But understanding, I'm planning on it. Yes, I am. Is there anything you want me to talk about or go over or give an example? Because there are tons of things like this, and algorithmic design of getting what you want to have happen. I mean, automation of data is the backbone of data engineering. I'm taking streams of data, chunks of data, unpacking large amounts of JSON, large JSON objects, and then placing them in tables in nice, pretty arrangements, so then other people can work with them. So there's so many different aspects of just using Python and SQL and pandas and all these things alike. All right. CBD, you don't have to tell me where you are, but just tell me the time where it is where you are, so I can kind of have an idea globally. Let's see. So now, this is what I have. So this is a perfect example of just unpacking a JSON object. So it was a dictionary. Made a sort of guessing game, but it's not showing some sort of error. Okay. We can work on that because actually earlier this week we wrote a script, a function to let we pick a number and then 7 p.m. there. Awesome. That is very cool. Actually, I don't know if you've heard of the Code Dam website, but I wrote a few courses for them. They reached out to me a few years ago, probably 5 years ago. So I haven't talked to them in a while, but yeah, I would say probably a third of my views come out of India. It's crazy. It's very interesting. Well, I'm glad you're here, CBD. Thank you for joining us. All right. So since I have this object and it looks like this, I want to extract these numbers. So, because a layperson, they don't want to read. They don't want to go, okay, what is this? It's 6 and then a 9 and then what? Okay. So we need to make this prettier. So my combination is the dictionary. My count as I go through, here's my key and here's my value. And my value is a dictionary. So now I need to unpack. So this is where this gets weird. So check this out. But understanding shape and scope. Tharva? Say that right? Let me look at something. Okay. All right. Awesome. Okay. Well, thank you for joining us today or evening where you are. So now let's look at this. So if I never be afraid to do this right here. So this is a dictionary. So a dictionary has a key and value. So when I go here, then I pass in another key, which this is again completely legal because we just proved that this is a dictionary. So this is going to be a key because as we can see right here inside this dictionary, 6 is a key. So when I call this, I get 1. All right, does that make sense? So now I need to unpack all of this. So let's see. So I have the count. Then how do I want this to look? 6 piece. So I have that, this. Let's see. Let's see if we like the look of this. And this will be our template. And I close that out. 6 piece 1. Do we like how that looks? One 6 piece. Let's change this around. Come back over here. One. I don't know. 6 piece 1 6 piece. I can't decide. I don't know which one I like better. I don't like either. I think I like this one worse. Hang on one second, everyone. Hey, you want me to feed him? Yeah. All right, guys. I gotta go feed the dogs. We'll be right back. Nico, don't let anybody drop. I'll be back in like 3 minutes. Yeah, it's on the side's fine. Hang on, everybody. I'm almost done. Thank you, Nico. Have a great day. You be safe, okay? Put some lotion on your face. I am. Is it hurt? Not bad. Okay. I slept with like Vaseline all over. Good. All right, guys, I'm back. There we go. Thank you, Nico, as always. Okay, so let's just go with this one. I don't love it, but I hate the other one more. Let's see. Did I get the lighting back better? All right, we're at an hour and 12, so we'll wrap this up. Is there anything tomorrow we want to kind of think about going over? Tharvad. I am going to live stream tomorrow, so if there's anything you want, just be thinking about it, and make sure if you haven't joined the Discord, make sure you're joining the Discord too. All right. Okay. Don't like this. So let's do and run this. Oh, that's gross. So when I did the other way, it was cleaner. Interesting. Oh, I was suppressing the new line. Duh. 6. So if I do 6, because that's our count right here. This is our count. Then this is my dictionary. I know how I want to do this. Here we go. So then that's the dictionary. So F string. Everybody knows the F string who's here. And we did 6-piece open, closed, and then six. Is that right? We're going to find out here in a second. Boom. There we go. So now we're going to do this line by line. Copy. No. Paste. Paste. And then print. So it's 9-piece, 20-piece. We could work on padding if we want to, because this would be a good example of wanting to improve the padding. All right. Okay. And if you are completely new here and haven't heard me say this before, I am not a speller. So we have a bug somewhere in here, because this is completely wrong. 19, or that can't be right. No, 2. So what do we have going on here? Because when we check combinations, combination, all right, combination count, then $19. All right, let's see if we can figure out where we're getting 19. We're getting am I really gonna have to put this on one line? Is that really it? That's gonna be ridiculous if that is how this is acting, but it is looking like this is exactly what this is doing. All right, I'll play along. And then yuck. Okay, let's get rid of all of this. And and run. Oh, okay. It was concatenating. I did need that to be okay. Now I get what I was doing wrong. Space, space. Delete. Space. Delete. Oh, need to bring this back. Run. All right, so now I cleaned all this up. 6-piece 1, 9-piece 2, 20-piece 1. There we go. So this is a lot neater to me. So let's change this and go 101. Now I can do this. And now I have a list. Check this out. I don't know. I have a list of, so I could keep this, have it, and go, all right, I want 66, a count of 66 nuggets. And, oh, that's an easy one. No, I want, there we go. What is this? Guess we could do some very obscure. What's the weirdest combination? I guess it's 1. Because 120 count and 999 counts. I don't know. 81. We have, oh, that's an easy one. 73. 73, not 72. Yeah, there we go. 1 6 count, 3 9 counts, and 2 20 counts. Because I want 73 chicken nuggets. Okay, everyone. Let's see where we are. We are at an hour and 20, something like that, an hour and 20 minutes. Okay, is there anything pressing about any of this that we need to talk about how I designed this, what steps I did to decide? Because these little subtleties right here, I know this makes sense, but this part of human brain of how I optimized this, because I think the old way that I did it is I cheated and I picked an arbitrary and made this 10, and I just went through 10 times, 10 times, 10 times, and then my next time through, I think I made it where whatever the largest was, 1, and I kept optimizing this. And that's the point of all of this, is to get it to work, and then how can I make it better? How can I make it catch everything? How can I do it with an edge case? Can I do it faster? Because with this, because before I was doing it, what, eight times? So 8 cubed, 8 times 8 times 8. It was 512 times. So I was running through this loop 512 times for where I really only needed to do it 80, was it 81? Because it was 8 times, it was 80. 8 times 5 times 2. So that subtlety of knowing what is the max combinations it could be saved us, oh my goodness, an interval of 432. Sorry, there's an alarm going upstairs for another kid who's got stuff they got to do today. I think that one's got to go to work. So who knows? All right. Anything pressing? Anything we want to talk about? Any questions we have before we wrap for today? Let me check something. Nico, is there anything pressing? Everything going well with your projects that you're working on? Because I'm trying to think of what we want to do tomorrow. I know there's plenty of things. We could work on Um, sorry, I found an old file here. This is why documenting and making comments in your code is important, because I have no idea what this one that I'm trying to read right now. Let's see. I think Nico why do you need to know how to get 51 chicken nuggets? That's a good question. So what the whole premise of this is you're going to have things similar to this. You're going to get stuck in, sorry, very sore, and I've pulled something on my back. Is algorithmic design. This is what I'm trying to convince the community, that algorithmic design is going to be, if you do anything similar to anything adjacent to data analysis, anything, it's going to be this. I'm going to loop through data. What is the fastest way to loop through data? So when I first did this, I just set it to 10. So I went through and I wasted so much time. I actually went through and defaulted this to 1,000. So I had 10, 10, and 10. So 10 cubed is 1,000. So don't get hung up on why am I doing 51 nuggets. Look at its subtlety of the complexity of this algorithmic design, because you're going to, I promise you, this counter right here, you're going to run into this, because you're going to need to find the most efficient way, because you don't want these counters to be 10 and 10 and 10. You want to optimize this and make it 8, 5, and 2. That's the point that I'm trying to drive home. How can I make this cheaper? How can I make this faster? How can I make this better? And human brain efficiencies moving into Python brain make things faster. So same thing like when I talk about the number triangle. That problem of iterating through a step, pulling stuff out, even this right here, understanding your dictionary object and knowing how to handle it, because you're going to be given things like this if you move into even programming. If you have a bunch of base code and you don't understand what the objects you're getting back, the attributes that are being inherited, all of these things are all the same. Same thing like our Monty Hall problem that we did yesterday. It's an exercise of taking a human decision and writing it into blank decision. Python, SQL, VB.NET, Java, any tool that you have, input programming language here, and you want to be able to do it. So don't get quite hung up on why you would need to do this. Can I do it? Can I write an algorithm to solve this decision for me? Because I promise you, when you have issues like this, let me say that a different way. You're going to have an issue like this because you're going to have a complex problem that somebody wants you to solve, and you're going to be like, oh my God, where do I even start? Or if I'm going to create a button in an application, what all does that button do? Is it going to search a table? Is it going to write to a table? Or is it going to search a table, write to a table, and update a table all at the same time? And you're going to algorithmically have to design how all those happen, because they're going to have to be in a certain number of steps. And if something is out of step, you're going to miss writing data, lose writing data, or screw something up completely. So that's what I'm trying to really articulate here, is that don't get hung up on 51. Get hung up on, wow, this is brute force, and I need to make this as efficient as possible. So it's search, it's brute force, it's algorithm. It's basically everything you're going to need to do to solve problems that you're going to be handed in real life by either a business partner, a project manager, an architect, however. And you're going to need to think through this, because I mean, honestly, I mean, this is exactly that. It's the same animal, just with different spots of everything that I was given. One of the last applications I was building before I left was, I had, was it 4 tables? And they were feeding into each other, because we had buckets, and each of those buckets split into buckets. So we had packaging, then we had packaging defects, and then each of those defects had sub-defects. And as we were updating, if they wanted to come and rename anything on those lines in those tables, it would automatically update, and then everything up the food chain would feed off of that table. So, all right, I know I'm a little bit rambling right now, but if there's anything you guys want to see for tomorrow, please make sure you're jumping on Discord and putting anything over there that we can look at tomorrow and talk about. So if you've not hit that like button, go ahead and please do that now. If you've not hit the subscribe button, we're doing live streams basically every day. Don't quite know exactly what we're going to do tomorrow, but I just really like this example here, because it covers a lot of decision, mimicking human decision. And that's what I guess I'm trying to share, is when I was really learning and I was struggling learning Python, and I would see how something happened in our world, I'd be like, how could I write an algorithm to mimic that decision? What did we do? How are we making that decision? How do we go about? How did we do that? Because that's all a computer is mimicking our human decision making. So, all right. If there's nothing pressing right now, Nico, if there's anything you want to ask, discuss, check on, hope all of your projects are going well. Arthavad, hope your guessing game is going well. Let's see, what did you say? Made sort of guessing game in Python, but it's showing some sort of error. Well, you'll figure it out, and just make sure you understand. That's probably the next biggest thing after that is, do I really truly understand what the error is? Let me see something. Oh, sorry. Everybody wants to be funny at my house today. All right. So, understanding what the problem is. So you may be trying to fix something that isn't broken. So when I was concatenating my list yesterday or the day before, I didn't understand what type of object I had, and I was trying to, thank you, Nico. I was trying to basically do this, because I quickly was moving through and I did this right here. This is completely illegal, actually, if we do it 100% of what I did yesterday. So the error looks exactly the same on the streams. It was this. So whenever, and I would get two different errors because the way that Python looks at this is order of operations. It's going to look to this and go, okay, you have an integer and you want to add it to another integer. Boom, throws up because it goes, hey, this isn't an integer. This is something other than an integer. We cannot do this operand. All right, so understanding what you have at hand. And the more you understand it, the better you're going to be able to solve it. So that's the, if you haven't noticed, that's the same theme that I just keep saying. And that's actually going to be what my probably first LinkedIn video is going to be, is making sure, because I actually have that line in there. Do you know the problem? And then I say, do you really know the problem? Because that's what it is. And the more you understand what the problem is, the easier it's going to be to solve it. So when I click this, it tells me exactly. And when I read that, it's so not just reading this and stopping, because this is frustrating. You don't have all the information. I got an error. Oh, I got an error. Okay, unsupported. Wait a minute. Okay, because I can't do this right here because int and list. Wait a minute. Int and a list. And my brain went, well, I'm adding lists together. No, I'm not, because I had two lists that I sliced, and I had another list where I indexed. Oh yeah, it was the horse racing one from a few days ago. Why does the NaN key not exist? All right, Nico, ask me that a different way. NaN, like an actual key for NaN, or that, because NaN, none, null, those are all the same things, just in different environments. So NaN is it's either NumPy or pandas. So we can look at this real fast as dir mp let me know pqrs. You can use none but not NaN. Right, hang on. Let me see if this answers your question. Tell me if this helps you. Does that help you? Because NaN is in the NumPy library. In Python, it's none, which is still the same. And then in SQL, it's null. You can still be returned NaN, but you can use NaN as a key. But you can't use NaN as a keyword. Sorry, they're being funny upstairs. So we do help on python.nan or NumPy. So right here. All right, sorry. I want to make sure nobody's killing each other upstairs. So I can. You're saying I can assign it. Is that? Are you? Don't get hung up on. So you're talking about that right there. You going? All right. I'm probably gonna end here in a minute, but you be. Oh, okay. Then I'm probably gonna be done. All right. And then you have null and pandas, I believe. Import pandas as PD dir on PD. Believe is null. Try JKL. Yeah, it's not. It's in a. Yeah, is in a. Not in a. Not null. And I thought it had a null value. Maybe it just shows up blank. Is null, is in a. But yeah, just in a, null. All those are the same. Trying to remember, but yeah, just don't get hung up on the semantics of what it is. It's just because you get into an issue when you have a blank. It's like how do you because it's not zero, it returned none and it wants you to know. So it's a placeholder for nothing, but you don't want to assign zero because I want you to be able to differentiate between a zero and it came back nothing. That's the way that I've always remembered and associated that. Because zero, it's like, hey, I had 9 minus 9, so I got 0. So there was something there. But now if it comes back null, it's like, hey, this was, it didn't do anything. We didn't do anything over there. So there was no activity. It was null. It was nothing. So that's what I want you to get out of that. Don't get hung up on what to name it, because then you go back and you're like, all right, do we want to say blank? Well, it's not blank. That's got a string in it. So the null value, you can search for them, but you understand that there's no data. So it's like, hey, I'm going to put something there, but it means nothing, but we're going to use the same term so you and I both know that nothing was there. So I hope that really helped, because I know null values are weird. So it's like, yeah, it's a weird concept, and I completely understand getting hung up on it. All right, anything other super pressing? Because if not, I'm gonna wrap. We'll head out for today. And we'll try to do something cool tomorrow. Don't know exactly. I know that there's more because there's tons of stuff. We could actually look at pickling and passing in global objects from function to function, because we looked at global yesterday. And then pickling is a great way to store a variable. You can actually assign it and save it to the hard drive. Yeah. Oh, it shows 7 likes. I see 8. That's why I'm not quite sure. Well, it all depends on what I'm going to do. If I need to do something until something else happens. But all right. Okay. Let's head out, and we'll check in tomorrow. And go ahead and drop over in on Discord. There's a link down in the description below. And if there's anything we want to talk about tomorrow, but if not, I'll see y'all then. Thanks, everybody. Bye.